Hi, I am Lopa Mudrashen. Welcome back to my channel Electronic Science Tutorial. From today I will start a new lecture series on NTA UGC NET and West Bengal SET exam for Electronic Science subject. Those who are not check out my channel, please follow my channel. If you like my channel, then please do like, share and subscribe my channel. So let's start our class. In today's class, we discuss about the NTA UGC NET and West Bengal SET exam 2022. In this session, we cover in detail about this topic so that we can easily solve the previous year question paper of UGC NET Electronic Science. Each and every topic we can understand in easy and simple manner. So, let's begin our NTA UGC NET exam 2022 class. Okay. Today I will discuss about the next important topic of extrinsic semiconductor, that is what is the energy band diagram or what is the position of Fermi level for n-type semiconductor. We know that is extrinsic semiconductor is two type, that is one is n-type semiconductor in which majority carrier is electron and minority carrier is holes, and another one is p-type semiconductor or p-type extrinsic semiconductor in which majority carrier is holes and minority carrier is electrons, right? So in this session we discuss about what is the position of Fermi level for n-type semiconductor. One more thing, that is for n-type semiconductor we know that is group 5 element like phosphorus, antimony, right? Phosphorus, antimony, arsenic is doped and it produces excess free electrons. So now we see the position of Fermi level for n-type semiconductor. So this is the band diagram for n-type semiconductor at absolute zero temperature, where EF lies near conduction band. Why it is lies near conduction band, we saw it. Here this is the donor line. If we consider one line just below the conduction band, it is represented by donor label. We talk about this topic in previous slide, right? So this is the donor label and which is represented by ED. The free electrons coming from the donor atoms fill the state near the bottom of the conduction band. Hence, it is more difficult for electrons in the valence band to cross the band gap by thermal agitation. Therefore, the number of holes in the valence band decreases, right? As the Fermi level EF is the energy for which the probability of occupancy is half. Fermi level, we know the Fermi level is the highest occupied energy level. So EF must move closer to the conduction band, because in the bottom of the conduction band we saw the donor level. So EF is the highest occupied energy level, or the Fermi level is the highest occupied energy level. So EF must move to the closer to the conduction band for an n-type semiconductor, right? This is conduction band, this is valence band, and the distance between the or gap between the conduction band and the valence band is called, we know, forbidden band. For intrinsic semiconductor, EF lies exactly middle of this band gap. That means EF lies exactly middle of the conduction band and the valence band. But when we talk about the n-type semiconductor, where donor level is create, that means one excess electrons level is create, and which is lie near the bottom of the conduction band. Bottom of the conduction band. So the free electron coming from the donor atom fill the states near the bottom of the conduction band. So it is more difficult for the electrons in the valence band to cross the band gap by thermal agitation. Therefore, the number of holes in the valence band decreases. As the Fermi level EF is the energy for which the probability of occupancy is half, EF must move closer to the conduction band for n-type semiconductor. So, for n-type semiconductor, this is the position of Fermi level. Right? Okay. Thus, when the temperature of n-type semiconductor increases, the Fermi level moves toward the center of the band gap. So, this is the position of Fermi level for n-type semiconductor at 0 Kelvin. Okay. Thank you. I hope you love this informative session of NTA UGC NET or West Bengal SET exam. If you like my video, then please do like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.